system can be exhausted somehow. And then you have to decide, do I do a FIFO drop? Do I drop the old records? Do I drop the new records? Do I do a reduced sampling, only process every 10th request? Either way you do it, you're losing data. The reactive streams are a little smaller. Just think about it. If you have a series where you have events flowing through the system or Spark, and you have one database which stores Spark users. Now imagine this database is going down, or this database cannot cope with the load anymore. Then you have the stream, and the fifth element in the chain is too slow. This chain element can tear down the entire processing queue. Reactive streams are a little smarter than this. Usually the data is pushed from the first system to the next system, from the first to the next. Then when one of the systems gets too slow, it switches from a push to a pull mechanism. It says to the predecessor, stop bugging me, I'll come and pick the data up when I'm ready. This usually leads to that the predecessor element gets overloaded, and this whole failover can propagate itself to the stream up front of the source. And the source is your last line of defense, which has to deal with this. That's the beauty of using a system like Kafka as a source. Because if one of your systems gets too slow, it'll propagate or it'll go to the fallback mode. Kafka is going to store the events for you until the congestion is resolved. Then it switches back to a pull mode and pulls the data to full speed again. So you have a resilient system which you don't have to immediately jump to it when the first little error pops up. And you're not losing any data. Does that make sense? So, Akka implements reactive streams. Spark implements reactive streams. With Spark streaming 1.6, which is out now, you can also consume this data coming in as reactive streams. The Kafka is just the perfect candidate for a bound buffer because it can bind terabytes of data for you. We have days to react to a problem, not minutes. And the nice thing is, when the system is falling to the fallback mode, you can have Mesos recognize this, and Mesos is to start scaling up the system. This is not instantaneous. If you add machines to a Cassandra cluster, it's going to rebalance the cluster and redistribute the data. Kafka needs to replicate the data. So you have upscaling that instance silver bullet. It needs a couple minutes, maybe even an hour or two, where the system gets rebalanced and as fast as it reaches full speed again. But in this meantime, you can have Kafka to collect the data for you. Does that make sense? Okay, we're getting to the end. I mentioned this before, I was really impressed by F#. Never really watched that because of .NET. Last thing they thought was 8.0 in the first versions. But we Java guys have F# too, just call it Scala. Scala is a mixture between functional programming and object-oriented programming. And so why do you need stream? Why do you need functional processing? Because streams will be processed in parallel. When you have an event stream with millions of events per second, you need to scale. You have to distribute this on multiple machines. So you're doing this in parallel. If you're doing something in parallel, you're in the concurrency accounting. If you did old school Java, old school C#, and you have to deal with thread monitors and stuff like that, you just don't do this. So here's some hygienic things you have to consider when you're programming this. You want the events to be immutable. When an event is coming in, and one client is modifying the field and passing it to the next, you're breaking the system. Sooner or later, you'll have race conditions. The consumers could pass each other, it may have a mess up. So what you do, take an incoming event, process it, and put out the next event. This is pretty much what Rachel said this morning, with the input output mechanism. Because when does this happen? When do these problems happen? They always happen in production. These are the things where the log files, we said, I don't know what that happened, so it won't happen again. These are the things which always cost you days and days of operation and working on tickets where you're actually turning out new code. So just have immutable systems. Functions, at least in German, probably in English too. I hope I used the right word. It's very concise and precise. formulation, it's scientific. Function means that it does not have any side effects. No matter how often you invoke the function, it's the same parameters and always get the same results. If you're thinking of servlets or ASP pages, and you're storing the state in the instance, then you can have different responses to the same request. You're breaking the paradigm of having those side effects. So this is a language like a sharp in Scala. They really make it hard for you to create these side effects. You can break it like any system, but that's the beauty of it. That's the beauty that it supports you. And the next thing, I like JavaScript a lot, actually. I don't have enough customers who let me do this, but one of the nicest things about the JavaScript, which I discovered, is that you can use functions to pass them around as parameters. And this is exactly what you need for language like this. You don't just pass data around, you pass functions around. Callback help. Know anybody? I think we're running out of time. So, yeah. Just want to reuse your code. I think this is why Sharp and C# is so efficient. I don't care about boilerplate code too much. I write this down automatically, but if you want to reuse your code, it's much easier if you can pass them around as parameters. I'm going to share the slides later. This is some Scala code. It's basically what you guys see before in the Sharp code. I won't dig into much of this now. Questions? Feedback? Okay, I'll say thank you.